All right, guys, welcome back to the week 3 lessons. So in this video, I'm going to talk about packages, and this should be a relatively short video. So packages, like we've already been using a lot in this video series, they are basically a way to group related features together in Go. Okay, so Go has over 100 standard packages. Okay, so these are packages that were being maintained and was written by the Go developers. And of course, there are other several thousands that are being written by a really thriving Go community. Okay, so packages are just a way of helping developers, Go developers, group their you know features together. Okay, so this is mostly to help make managing large programs really easier and a bit more practical. Imagine a code base that is 50,000, 100,000 lines of code, and you just have it in a single package, maybe on a single folder or in a single file. I mean, that is unreal. It's impossible. Nobody can manage that. I mean, you have to be a robot to be able to manage a program like that. So packages sort of make these things really easier for us to do. All right. So packages introduces things like encapsulation. All right. So what that means is encapsulation, in the sense of OOP, simply means hiding data or hiding implementation from where it's not really required to know what's going on. Okay, for example, packages that we've used in the past, the FMT package, the run package, it just hides so many things away from us, things that we don't have to worry about. Just import the package and use those functions that have been made available to you. Okay, so it encapsulates data and controls visible things and non-visible things. And if you want to have a method that is just specific to that particular package, you can easily do that, and by not exporting it. If you want to expose an API to your package, you can do that by capitalizing your function name and your package member names. Okay, so I have an example here, and the already familiar package main, which is the main package, and this is our import parts. This is so after the package main, we can import so many things. So all these in here are part of the package system in the Go programming language. All right. So the import keyword is used to import packages, and as you can see, you can even do relative imports. So we are importing the run package that is within the crypto package. Of course, you should be able to do something like this and it should work, but we don't want that. So we want the rand that exists in the crypto package. It's sort of namespacing, yeah, sort of namespaces some of these things using those stuff. So you can group your features, your functions, and your structs in a specific namespace, and you can access them from that namespace. All right. So yeah, as you can see what's happening here, we have two packages that have the same name. To avoid conflicts, you can type the name that you want this package to take, and that is what you will use to access it in your code. All right. Also, we have what we call blank imports. All right. So in Go, there is a function called Go. Okay, so this is something I didn't mention in the past. All right. There is a function in Go that is called the init function. So it's a special function like the main function. Okay, so the init function is a known function. Specifically, it's actually a reserved name. All right, it's peculiar to packages. So when Go is loading every package, it has a series of things it has to do, like things like reading object files and the way it actually locates these packages. There are mechanics to that. All right, I don't want to go into that because that it's a bit out of the scope of this course. So the init function is what the Go compiler calls when it is loading or importing a package. So for example, when it's importing the FMT, it checks for this init function. So it just calls it, and before it calls it during the package imports. All right. The another thing is that this blank imports. So the blank import actually makes use of this init function. So what this blank import means is that we are not importing this PQ package to use it in our code. We just want to register something. Maybe we just want to invoke the init function, and that's all. We don't need any functionality that is within that package. That is when you can do things like blank importation. Okay, so this is the Postgres driver for Go. Okay, so it uses the blank import to register the Postgres driver to the Go's SQL package. So that's why if you want to use the Postgres, you can import this library this way, and it gets registered to available drivers. So that way you can now open a connection to the Postgres database and do some computations. Yeah. So before the end of this program, hopefully we'll do something in that aspect. Okay. So the second line, following line, is for the MySQL part, and basically does the same thing. Registers the driver just by blank importation. So let's actually have a look at the PQ package. Let me think. Hopefully there should be init. I'm trying to see if we can find the init function somewhere here, and let me open this. So I'm trying to see if I can find where this driver was actually registered, and maybe if it's somewhere here, and just quickly check. Yeah, as you can see here, init. Okay, so the init package, the init function in our PQ package, this is what gets invoked. So as it imports it, it calls SQL.register. Okay, so this SQL is actually part of the Go standard library. You can see it here. So it's a library that that makes it possible for Go programmers to access SQL-based databases. Okay, so say you want to use Postgres, you use this particular package, the libpq, to register that to your SQL. So it just calls to register the driver to the SQL package. So once you import that, once you do the blank importation, this is the function that gets invoked, SQL.register Postgres, and passes the driver. All right, so yeah, that's that. All right, so naming packages, there are actually nice ways. So there are a few best practices when it comes to package naming, and it's something that you would maybe for now may not have to think too much of it, but it wouldn't hurt maybe if you could always have a look at it, and just few best practices on how to name your packages. And Go standard library tries its best to, like you will get a warning not to use things like what's it called, maybe a snake case to name your packages, maybe something like this. We rarely see something like this as a package name in Go, so they usually prefer everything in small capital letters, and and try to be a little bit unambiguous. Use shorter names, but not cryptic, like maybe I. What's I? I is I, so maybe use a name that makes sense, and you don't use names like util. Util is just general. Util for what? Okay, so being a bit more specific also makes makes your packages more intuitive and understandable. Okay, so let's quickly create a package and do some package importation, so you see how that works. So I'll create a new folder, and now I'm going to create a main.go. So this is going to be where our package main is going to live in, and so have a fmain. So now, if you remember the program we wrote in the last the program we wrote in the last video, so where we wrote a scroll feeds function. Okay, so let's repeat it, but we're now going to import this particular interfaces, and so you see how that works, how package importation and how to use external packages actually works. All right, So I'm going to go ahead and pause this video right now and import and do some cleanup so that I don't waste too much time typing this out. All right, so I did a couple of things when I paused the video. So the first thing that I did was to convert this project to what I call Go modules. Okay, so during the earlier days of Go, there are multiple ways of loading packages and managing dependencies in Go. So we had things like what we call Go dep. Okay, so had Go dep, and most recently Go modules were introduced, and I'm not so familiar with Go dep, but because I found Go modules to be really easy to use, and I just went with that, and most of the communities has been moving towards using Go modules. Okay, so the first thing I did was to initialize this package into a Go module, and to do that I just run a Go command in the console. So I'm just going to get rid of this so you guys will see me do it. So you say go mod init. Okay, so I just decided to call it Go training. Okay, so you can call it whatever you want to call it, and it's not a problem. So I'll just go ahead and call it this. So what happens is it generates this file for you that defines this particular folder, the Go training folder, as a module. All right, so what this does is it now gives you a path to access all of your packages. Okay, so I was able to import my week 3 packages. So everything that is in my week 3 folder that is exported, I can now access it through this week 3 namespace. All right, so down here, as you can see, I was able to access the Facebook struct by just calling week 3, and you can see that it's located there. So if I do something like this now, say week 3 dots, so you can see the suggestion. These are everything that are currently exported inside there, the week 3. Okay, so and let me go ahead and show you the full file now. So most of these things right here, this is actually where they are located. If I go ahead and run this code now, so as you can see, everything still works well, very well. Okay, so so what I did was just to separate my main package from the Victor package. Okay, so I created another folder in here called CMD. I like to put all of my executable inside the CMD folder, and then I imported my interfaces code, my week 3 code. So everything that is exported, so exported types or exported package members are everything that starts with the capital letter. I've said this before, so just to remind you of that. So everything that starts with the capital letter within this folder, the whole folder itself, not just the interfaces file, but all of the Go files in here are actually become exported and available to the external packages. All right, so this CMD is a different package from the week 3, in as much as it's located inside of it. It's a different package because if you check the name, it's a package main, and the one on the interfaces is called package week 3. They're 2 different packages. All right, so they still obey the mechanics of when 2 packages are trying to interact with each other. All right, so there's one more thing that I did. I decided to separate all my platforms code. I wanted to move them into a different package. All right, so realize that this is an example. That's why I have everything all inside of this week 3 package. So as you can see, I created a package called Facebook, and all the Facebook code is located here. Same thing for LinkedIn, same thing for Twitter. Now guess what happens to our interfaces file. See how really huge it is. Relatively big, it's not really huge. So it means I can now get rid of all these things here, all of it. Okay, and this is just what I have here now. So show me how to go. So now my code is going to break. Should it? Let's try and run this. See what we get. See, there's a problem. It can't find them anymore. Okay, so how do we fix that? We can fix that now by, I think we should we can actually try this. No, we should can fix that by actually importing them. So we can now do this Facebook and save that. So let me just comment these guys out. So same time, I'm going to get rid of this. So that week 3 it's going to be Facebook.facebook, and yeah, as you can see, helps me to import it too. So Go goes ahead and imports the victory because it knows I will need it. Okay, so for Twitter, I can go ahead and type Twitter. My Go FMT should help me import these things as I type them out. So once I hit on save, it helps me to import it. So LinkedIn, save that, imported to. So I'll now put these things back here. Twitter and LinkedIn, save that. Everything is looking good. So if I run this code now, everything is working well. So yeah, you can see how everything just now looks a bit more organized, and we now know that if we want to make changes to our Facebook package, we just go straight here, and the code is now less bogus and makes it a lot much easier for us to reason and look into. All right, so I think that's for, yeah, I think that's it for packages here. So in the next video we're going to look into error handling, and see you then.